In this video, we're computing the integral of cosine to the fourth x sine x dx, first by informally using the chain rule backwards, and that's usually what u-substitution is actually about, and then second by formally using the u-substitution. So the key to doing this informally is that you recognize you have a function of a function. The inner function here is the cosine function, and that's being raised to the fourth power. That happens to be sitting right next to the derivative of the inner function. And I recognize this as a result of using the chain rule to differentiate a power of the cosine function. Now there's some adjustments that have to be made because the derivative of cosine is not exactly sine x, it's negative sine x. So I rewrite the integral by multiplying the inside and the outside by -1. And now I've got a power of the cosine sitting right next to the derivative of the cosine. I recognize this as the result of the chain rule, and I can just guess the antiderivative of this interior piece. And that's just going to be 1/5 cosine to the fifth, just using the power rule. This is an indefinite integral, so I should have a plus c on there. Now, whenever you're using a less formal method, it's probably a good idea to check your answer. So all we have to do is differentiate this and verify it comes out to the original integrand. And that's good practice with the chain rule anyway, to improve your intuition for how it works. So the -1/5 is a spectator here. And then I have cosine x to the fifth power, so I differentiate that with respect to the cosine function, giving me 5 times cosine x to the fourth power, which we write like this. And then the chain rule says now you've got to tack on the derivative of the cosine function with respect to x, and that's negative sine x. And my 5's cancel, and my -1 cancels with a factor of -1 here. And I'm left with cosine to the fourth times sine x, which is the integrand that I started with. So we know this is right. Now, if you're going to formally use a u-substitution, you still have to kind of recognize what's the inner function here. And do I essentially have the derivative of that hanging around in my integrand? So you still have to recognize cosine x is the inner function, and that's the substitution that you make. So u is going to be cosine x, so this little piece out in front would be u to the fourth. Then I need to transform the differentials as well. So I write du is going to be the derivative of this times dx, so negative sine x dx. And so I'm still playing the same game as I did in this line of part A. I'm going to force this negative sine x to appear by multiplying the inside by -1 and the outside by -1. And now this piece is u to the fourth. And then the negative sine x together with the dx. That gives me du. My integral is now transformed to negative integral u to the fourth du. I guess the antiderivative, that's 1/5 u to the fifth plus c. And then finally, I replace u with its definition in terms of x. And we arrive at the same answer that we got informally. If you find the math content on Zach's Lab helpful, click on the Zach's Lab logo on the right to browse playlists and subscribe to the channel. I produce dozens of new videos per month, and subscribing is the easiest way to find new content. Thanks for watching.